Okay, a very good morning everyone and welcome to the chemistry class. So I hope you people are keep on revising the topics which we have covered in the last class. We have started with the very basics of the organic, that is the general organic chemistry, and we have covered almost, you can say the half of the GOC here, okay? Because we have started the major effects here. We have started the inductive effect, we have started resonance, mesomeric effect, and hyperconjugation. Okay, so today we will try to solve some of the important questions which are likely to be there in the exam, and then we'll do the further topics. Okay, so Shillong is there. Shillong, if you have the working camera over there, please share your camera port number here. The students from the Shillong Center. Are you people there? I'm just going to write the topics which we have discussed. Have a look and tell me if you have any doubt. So we have started with the GOC here. The very first was the inductive. The second thing was the resonance. Then there was the mesomeric effect, and then was the hyperconjugation. Anyone having any doubt? Shillong Center? Are you people listening to me? The students from the Shillong. Just write down so that I get to know that you people are there. Any doubt in the topics which I have written on the screen? Have you people revised the topics which we have covered? Just write down here, okay, so that I get to know that you people are there or not. Okay, I guess I'm able to see you, Shillong. Can you please raise your hands? The students from the Shillong Center, just raise your hands. Raise your hands. Nobody is raising their hand. Shillong, are you listening to me? The students from the Shillong Center. Just write down something on the screen, okay? Just type it down. Can anybody come forward and just write down something here on the screen? So one is the Shillong Center. If any other center is there, those who are listening to me, just write down, okay? Shillong, are you listening to me? How many students are there in the Shillong? Just write down with the help of the keyboard so that I get to know that you people are there. Shillong Center. How many students are present in the Shillong? I am able to see some of the students there, but nobody is raising the hand and nobody is writing anything on the keyboard. Why this is so? Okay, I am able to see some of the students in the classroom. Just raise your hands, Shillong. Raise your hands. Are you listening to me? Am I audible? I just want to know that how many students are there. I'm able to see some of the students there, but they are not responding. So anybody can just write here that how many students are present. Am I audible? The students from the Shillong Center. Are you there, Shillong? The students from the Shillong. How many students are there? Are you able, how many students are there? Have you logged in? Shillong Center. Okay, Shillong, are you able to see me? Can you please raise your hands? Can you please raise your hands, the students from the Shillong Center? Okay. Is there any other center other than the Shillong? Do we have any other center? If there is any other center, Itanagar or Sisipur, if you people are there? Okay, if nobody is there, we have some technical glitch over here in the Shillong. So we will be starting the class after the 5-10 minutes. Sisipur is there. Oh, okay, then Sisipur Center, there is some problem going on over there, the Shillong Center. We have some technical issue over here. We will be starting the class after the 10 minutes, okay? Just wait for the 10 minutes. We will be starting the class after the 5-10 minutes, okay? Just raise your hands. I'm able to see you all. The students from the Shillong Center, can you please raise your hands? Okay, thank you so much. Finally, we have the Shillong. That is so nice. I was waiting for you people. So I hope you people are revising the topics. As you know, we have started with the GOC. We have covered these topics which I have written on the screen. Sisipur, are you there also? Sisipur Center. So I have two centers with me, that is the Shillong and the Sisipur. Okay, so as you are able to see that we have done the inductive, the resonance, the mesomeric effect, and the hyperconjugation. Okay, I guess the hyperconjugation was the last topic which we were doing in the class, and I'm telling you this is the half of the GOC here. Okay, and the other half of the GOC is like the direct questions are. They will be talking about the stability of carbocations, carboanions, the acidic strength, the basic strength. Okay, so these types of questions will be there. So let us start with the few questions, and let me tell you one more very interesting thing, that we today we will be done with your the WhatsApp group also. So I will be posting one assignment today, and regularly we will try to do at least 2 to 3 assignments in a week, because as you know that we are particularly focused on the competitive exam for the NEET, and as I've told earlier also, that it is very, very important to solve the lot of number of questions, okay? Because if you solve the variety of questions, then you will get to know that which type of questions are likely to be there in the exam. So today I will be posting the assignment number 1 in your WhatsApp group, and please make sure this is not only for the chemistry, for the other subjects also. So keep on solving the assignments, and keep on asking the doubts on the group as well. We can have a good discussion on the group. Okay, and if you're not comfortable over there, obviously you can message your personal, personal message me your queries, right? So coming back to the inductive, resonance, and mesomeric, let's do one question. As we were doing the question, try one question, everyone. You have to, because this type of question we were doing in the last class, right? So you have to find the decreasing order or find the order for electron density in the benzene ring. You can tell me the decreasing order. We have already covered the orders, right? And you know that if you do not remember the order, you can simply solve the question by this method. Quickly do the question, tell me what will be the answer. You can take the help from the orders which we have written earlier. Try it, tell me the answer. You have to tell me the electron density in the benzene ring. Write down the order. You have to find the decreasing order of electron density in the ring. quickly write down the answer. Somebody come forward, type the answers, then we'll discuss. So what is the answer? 1, 2, 3, 4 or 1, 2, 4, 3? 1, 2, 3, 4 or 1, 2, 4, 3? Okay, how many of you are saying 1, 2, 4, 3? Raise your hands. 1, 2, 4, 3. Okay. Anybody with 1, 2, 3, 4? Anybody with 1, 2, 3, 4? Nobody? So it means you are getting confused in the cyanide and the carbonyl, CHO. Just have a look. We have written the order. Everyone, just look at the screen. This is, pretty sure that this is NH2. This is a plus M group. It's an electron releasing. You remember the first atom, when there is the electron containing atom, then it always gives the electron density to the ring. This is also a plus M group. But obviously, we know that from first and second, the first is more electron releasing group, right? Now, this is carbonyl. Just check the order. We have already written C double bond OH, and this is cyanide. You remember that nitro and cyanide are very much, in the front lining of that particular order. I'm saying that nitro is a very strong electron withdrawing group. Same is the case with the cyanide, because just after the nitro we have the cyanide. So they both are electron withdrawing. Now which one is more electron withdrawing? That is the cyanide, Shalong. Okay. So don't you think that there will be a little bit electron density present in the case of the CHO? Are you able to see this? So what will be the answer? It would be first, second, third and fourth, not the fourth and third. Why? Because fourth is the more electron withdrawing as compared to the CHO. Is this clear now? Is this clear to everyone? Anybody having doubts, raise your hands. Okay, clear. So what about the second one? Tell me for the second, I'm waiting. You have the phenol, you have a chlorobenzene and a simple benzene. What will be the answer? And just take care of the halogen, okay? I guess we have written this exception in the last class. So what will be the answer here? First, third and second. How many of you are with this answer? I got first, third and second. Raise your hands. Many of you. Very nice. Good. So you remember this thing? That first, then it will be third, then it will be second. The reason is that this is withdrawing, this is giving, okay? So we have also written this thing that in the halogens are electron withdrawing groups, okay? So because the minus I is dominating. And I hope there is no confusion in this thing, okay? So these were the very common and a conceptual type of questions which we have done. Now let's do some little tricky one, okay? I have one very good question with me, and this was last year in the NEET, okay? This type of question. I am drawing the structure here. You people can also do it. Draw the structures. The question is same that you have to tell me the electron density here, okay? This all is a one question, right? I'm doing the numbering. This is the first, let's say this is the second, this is the third one, and this is the fourth one, okay? Now just try, it's a very good question. First of all, you people try, because you know what happened in these types of questions, you no need to, like, you have to apply your brain, you have to think, okay, that which particular atom is giving the electron density and which is taking. There will not be the direct, like you have crammed the order and you will be directly doing that. No, you cannot do that. Try this one. Little tricky, but the easy question. You can do it. Just a little hint I'm giving you. You have to check the electron density in the benzene ring. So just check which is the first connectivity, which is the first atom attached with the ring. Whether it is the giving or whether it is taking. Okay, so you have to think like that. So what will be the answer, Shalom? Anybody got it? First, okay, fourth, second and third. Okay. A very little mistake is there, Shalom. Try to check between first and fourth. How will you compare between the first and the fourth one? This is quite obvious that in the second and the third option, that attaching atom is the carbonyl. So this is very good thing that you have solved the second and third. In the third, you got the two carbonyls, right? But I just want you to check between the first and fourth. First should come first or the fourth one should come first? Yes. Fourth, then first? Okay, first of all, look at the screen. Yes, that will be the answer, right? Those who are getting confused, any doubt, look at the screen. Whenever you see this type of question, obviously now you haven't seen these type of groups particularly in that order. So what you have to see, you have to check for the very first atom which is attached with the benzene ring, right? Everybody just look at the screen. So I am seeing that this is the nitrogen. So it's having the lone pair, obviously it will give it to the ring, okay? But at the same time, the carbonyl is just attached with it, so it has the option. This nitrogen has the option, it can give the electrons to the ring also. At the same time, it has to give some electron density to the carbonyl also, right? Now look at this one. This will definitely be taking the electron density towards itself from the ring. And here I am getting two carbonyls. Are you able to see that? It means the electron density will be minimum in the third option, right? Now in this question, in fourth and first, both are attached with the nitrogen there. But you know, here there is a gap of the carbon and there is the carbonyl, okay? So this nitrogen have to give only the electrons to the ring here. Are you able to see that? So what will be the answer? The answer will be fourth, then it will be the first, then it will be the second, and then it will be the third. Just to try it, I have written the order. So, and tell me if anybody having any doubt. Any doubt to anyone? You got it? How to do these types of question? Okay, thank you. Nice. CC-Pur Center, are you there? You got it, CC-Pur? Any doubt to you? CC-Pur. CC-Pur Center, if you have any doubt, just write it down, okay? So these are the things that how you will be dealing with the questions, okay? Now let's talk about some more questions. We have done the hyperconjugation also. So I can ask you this type of question, that you have to write the stability order. First of all, you people will try, then I will tell you. Write the stability order for alkenes. I'm drawing the third structure here below, okay? It's a, I have just drawn the three types of alkenes here. You have to tell me the order. How will you do this? Anybody having any idea? Because they will ask you, like when we will writing the reactions, then I will tell you that this is the major product, which is the more stable alkene. How you people will get to know that which is the more stable alkene? Very good, Chalong. So what will be the answer? Whenever you see this type of question that you have to check the stability order of alkene, you have to count the number of alpha H. Always remember that stability of alkene is directly proportional to the number of alpha H. Okay? So what will be the answer now? Obviously it will be 3, then 2, then 1. There is no alpha H, 0. Here the alpha H are 6. You know that these are the alpha carbon. You remember in the last class we have counted it. And here I will be having the 12 number of alpha H, okay? So whenever there is the more number of alpha hydrogen, then that particular alkene is more stable. Or you know that this line is written in the NCERT, that the alkene which is more substituted, okay, that will be the more stable. So either you can go by that method also, but this is the very common thing. The more number of alpha H, more stable will be the alkene, right? Okay, then let's do this thing also. I'm writing a question here again. This was for the stability of alkene, so this you people already know. Can you people tell me what will be the order of? I hope everybody has written it, okay? Just make a box and, whenever you see any concept, just star mark it. Right, okay. So write one more. What will be the order for? Or you can write what will be the decreasing order for heat of hydrogenation. You know what is heat of hydrogenation? Try it. I'm giving you those same options, but this time you have to tell me about the heat of hydrogenation. How many of you have the idea what is heat of hydrogenation? Raise your hands. No idea. Okay, a cross sign is there. No problem, just write it down, I'll tell you, okay? Because that is also related to something with the stability of alkene, and it's very simple, and we should know this thing also. Written? Now look at here. I hope everybody has written the options. The same options are there, okay? Now look at here. I hope you people know what will be the answer of this particular reaction. You people have studied it. What should I write for the product? Whenever you have any alkene or alkyne and you treat it with the nickel with the hydrogen, or platinum with the hydrogen, or palladium, nickel, platinum, palladium, both are of the, all these three are of the same group. When you treat it with, obviously, you will get an alkane. So this is nothing but a catalytic hydrogenation you are talking about, or I should say a catalytic reduction we are talking about. Addition of hydrogen is what? The reduction. So what I will be getting? I will be getting an alkane, right? That from an unsaturated compound, we are getting a pure alkane, okay? Now what is heat of hydrogenation, everyone? Heat of hydrogenation is the amount of heat released, okay? When the amount of heat released, like with this reaction, we are getting the heat. The amount of heat released when the 1 mole of unsaturated compound is converted into the saturated one. So this is the heat of hydrogenation. I am using the terminology HOH, okay? This is heat of hydrogenation. And I am writing it the amount of heat released when 1 mole of unsaturated compound is converted to saturated. Right? So this is the definition of heat of hydrogenation. HOH is heat of hydrogenation. Now you people will tell me that if this is the heat of hydrogenation, can I say something about what will be the delta H of this reaction? Enthalpy, I want to know about the sign, whether it will be the positive, negative, exothermic reaction, endothermic reaction, what will be that? You know this. Tell me. When the heat is released in any reaction, what is that reaction? Endothermic, exothermic? Discussion is going on for endothermic, exothermic. Yes, exactly, it's exothermic, Have you ever seen any reaction in your chemistry lab that you are doing some kind of experiment? I have seen that. Whenever we do any kind of any experiment is going on, and when you just touch that particular beaker or in which that reaction is going on, when you touch it, and it's little bit hotter, so it's warm. So it means that that reaction is releasing the heat. So it is the kind of reaction known as the exothermic reaction, which is having the delta H negative. So I can write here the delta H will be the negative here, okay? It's an exothermic reaction. And earlier when I was like you people, I get confused between what is exothermic, endothermic. So always remember exit means out, okay? Exit means going out. So exothermic means the heat is going out, okay? It means the heat is released. So you can just relate it. And reverse will be the case of the endothermic reaction. In the endothermic reaction, you give the heat. How you give the heat? You have to heat that particular container. You put the burner below, okay? And it means you are giving the heat, so that is an endothermic reaction. Delta H will be the positive there, okay? Now, a very, very common thing, everyone just look at the screen. I'm telling you how will you check the orders there. See, let's say I have written this reaction, okay, and this is an alkene. Obviously, it will be happy to get converted into the alkane. The heat is releasing, it means the reaction obviously wants to go in the forward direction, right? Because reaction wants to happen. It's so much clear that everybody wants the stability. You people want stability, I want stability, everybody wants the stability, right? Same is the case with this ethene also. This ethene wants to get converted into the more stable compound, which is an alkane. The alkanes are always more stable as compared to any unsaturated compound, right? So obviously heat release will be more. That is it, okay? Now, if I compare this reaction with this one, like CH3, CH double bond CH2, and I'm giving again performing the same reaction. So obviously it will also get converted into what? A propane. But I am saying that we have the two types of alkenes here, okay? What will you say? The number one or the number two, which will want to get converted into the alkane, or which will be fastly get converted into the alkane? Think about it. See, here I'm talking about what's the question is, like I am saying, the first alkene is obviously the unstable kind of alkene, which wants to get into the stability, okay? But like the second one alkene is comparatively stable than the first one, okay? So this is how you will be judging the order of the heat of hydrogenation. Always remember the heat of hydrogenation will be more for the lesser stable alkene, okay? Like in this case, I will be getting the more heat. More heat will be there because this alkene was lesser stable. Everybody got the concept? Tell me you got it? So this is how you will be checking the heat of hydrogenation, okay? So can I write this thing now? That heat of hydrogenation, HOH I'm writing, okay? It's not H2O, don't write it, obviously. It's HOH, okay? Heat of hydrogenation. So heat of hydrogenation is inversely proportional to the stability of alkene. And we know how to check stability of alkene with the help of alpha H, okay? So the one with the more number of alpha H will be the more stable alkene, which is having the lesser heat of hydrogenation. So what will be the order now? First of all, do write this thing, okay? Just make a box. These all are the conceptual things. Okay, so I hope this is clear to everyone. Now, what will be the order of that question which I have asked you? That heat of hydrogenation, what will you do? Yes, so exactly the answer will be the first, then second, and then third. Okay, so this is the answer for the heat of hydrogenation. Clear? Clear to everyone? So we are done with the stability, we are done with the heat of hydrogenation. Good. And we are also done with the electron density type of question. Okay. I have one more question I want to ask you for this electron density. I'm so sorry I left one question. Because whenever I ask this question here in my live classes in Delhi, the people get stuck. One question, okay? The order for electron density. A same question from where we have started. Just one question, okay? Do it again. I have a toluene with me. This is toluene. and I have a tertiary group here. Which will be increasing the electron density more to the ring. Think about it and then tell me the answer. Take it as the first one, take it as the second one, and now tell me the order. What is the answer? First or second? Which will be having the more electron density? First reason. I want the reason. How many of you are with the first? How many of you are with the first one? Raise your hands. I'm saying that how many of you are with the first one? Just raise your hands. 1, 2, 3. Okay. And how many of you are with the second? Because, this is a very kind of, it's a controversial thing. That tertiary is there, so it will be having the more plus I. Anybody with the second one? Nobody is with the second one. Then the rest of the people are with which one? We are with no one. So nice. What happened to the other students? Second. Okay, I got a hand raised for the second one. And still, what about the others? Since there is only one carbon in the first one, there will be more electron density. So, what we can say that if it has only the one carbon? It's not... It's kind of, incomplete statement which you have written. Although your answer is correct, the first will be having the more electron density, but the explanation is not, it's improper, What I usually hear from the student is, they say that, ma'am, tertiary is, as you have already studied, I guess, that tertiary carbocation is more stable than secondary, than primary, right? 3 degree, 2 degree, 1 degree. So they apply the same funda over there. That tertiary 3 methyl groups are there, so more plus I will be there. And in the first one, I have only one methyl group, so inductive effect will be lesser. No doubt the inductive effect of the second one will be more as compared to the first one. But the more dominating here will be the hyperconjugation, everyone, okay? So you have to check the alpha H. Again, the one with the more number of alpha H, here the alpha H are 3. And here there is no alpha H. The alpha H is 0. This is the reason that this is more electron releasing as compared to this one. Although both of them are electron releasing, okay? But I have to say that first will be having the more electron density than the first due to the hyperconjugation. Okay? If I compare the hyperconjugation, it will be more of the first structure. But if I have to talk only about the inductive effect, then I will be saying that inductive effect of the second one is more. Okay? Now clear to everyone? And please, star mark this question. This is also very important and you should know this. Don't do the mistake in these ones. And if I now write a collective order for the inductive resonance or for the hyperconjugation, It should be like, always remember mesomeric I should write. The mesomeric effect, it's kind of, you can say it's mesomeric or it's the resonance. Because mesomeric is nothing but a special case of the resonance itself. So it will be more dominating. Then hyperconjugation. And this is not only for the stability, you can apply it everywhere. So you will see the application where we will talk about the carbocations, carboanions. And then we will have the inductive effect, okay? So this is a collective order. Just write it down. Then we'll start with the carbocations. Sisipur, if you have any doubt, just write it down, okay? Are you getting it, Sisipur Center? How many students are present in Sisipur? Write down the number also, okay? Let's start the new topic. You know what are the reaction intermediates? Intermediate is something which is, the name itself suggesting that which is forming in between the reactant and the product. If I have a reactant, I have a product, something which is forming in between. You people have studied SN1 reaction in your 12th class. In the SN1 reaction, you people used to form the carbocation over there. So that carbocation is your intermediate, right? When we will be talking about the, the reactions, then it will come over there. But let's start with the very first. I'm writing the common names here, like the common name of some intermediate which we will study. Carbocation, carboanion, and the carbon-free radical. There are some other intermediates also, but they are not so much in our syllabus. Like benzene is there, carbene is there. So we will not be talking much more about them. We'll see there are only one or two reactions in which the benzene or carbene is introduced. Okay. Let's start with the very first one, carbocations. I'm going to write the few things about the carbocations. You people will also write. I'm making a structure here, okay? Let's say I have, not like this. This is a carbon. Let's say CH3 is there, okay? And one positive charge is there. So I have made the 3 bonds. It's a very similar structure, like let's say if I have the CH3+. I'm talking about the methyl carbocation. You people will tell me the hybridization. You people will tell me the hybridization. How many of you know the hybridization? Just raise your hand. The hybridization of the structure which is there on the screen. Yes, you should know it, okay? It's a part of chemical bonding. 1, 2, 3. 3 bonds are there. So what will be the hybridization of this one? This is sp3 or sp2? sp2, na? sp2, right? 1 s orbital and 2 p orbital. 3 orbitals are mixing. I'm getting the 3 new bonds, okay? So it's a sp2 hybridized. What is the geometry of sp2 hybridized compound? I want to know the geometry. Yes, tell me. That table of the periodic table, the geometries, the shape, the linear octahedral bent, you have studied all these things. It's very, very important. Direct questions are there. Yes, so it's trigonal planar. So it is the trigonal planar, right? Can I write that this is an electron deficient compound? Obviously, it is an electron deficient compound. The octet is not completed yet, so you can also write these things. It's an electron deficient, the octet is not completed. Okay? And simply just tell me, electron releasing group will stabilize the carbocation or electron withdrawing group? Tell me if we want to check. Which type of groups will stabilize the carbocation? Electron releasing or electron withdrawing? Think about it. See, whenever I am saying that we have to write the stability after of the carbocation, it means that you have to minimize that positive charge. How will you minimize? Always remember, you have the positive charge. It means the groups which give the electrons to that positive charge will minimize it, okay? So always remember that electron releasing groups stabilizes the carbocation. They can be plus M groups, mesomeric groups. They can be plus hyperconjugation or plus inductive effect, okay? So all these kinds of groups stabilizes the carbocation. Do write it, okay? And then we will start doing the questions. We have to write the stability order of carbocations. Now we are aware that we know what is inductive effect, resonance, everything. We know the orders also. So we have to find the stability order here, okay? Let's try. This is a very common question. I'm writing it as the first, second, and the third. Tell me the order. What is the answer? First, second, and third. Raise your hands. How many of you know the answer? I'm saying those who know the answer, just raise your hands. 3, 2, and 1. How many of you got this answer? Raise your hands. 3, 2, and 1. Okay. What about the other students? We are not raising the hands. Why so? Yes, this is the answer obviously, because this is actually for the methyl. It's again plus hyperconjugation plus inductive effect. I have 2 methyls here, and here I have 3 methyls, okay? So, and one more thing I want to add here, like we can also write this is 1 degree, this is a 2 degree carbocation, and this is a 3 degree carbocation, okay? So 3 degree carbocation is the most stable, then 2 degree, then 1 degree. So what will be the answer? It's obviously 3, 2, and 1, okay? Let's do the second question. Try this question now. I am just editing this structure, okay? Just change the structure because it will be difficult to compare then. Yes. Now you people will tell me. The first and the second. Quickly write down. The first and the second. First. Why? I have just edited the structure. Check your structure. You have to simply check what, this time there is no group present over there, so you will be checking the resonance. So which structure is more stable, Shillong? Second, obviously, okay? So second will be the most stable due to the resonance, okay? So you can write this thing. Explanation you can write by your own also, that due to the resonance. If, the resonance is present, it means that positive charge can delocalize all over there in the structure. So if there is more delocalization, more will be the stability, right? Clear to everyone? Any doubt? Last test, any doubt? 3 students are sitting on the last? Yes, 3 are sitting. So I hope there is no doubt. Let's talk about the next question then. Try this one. pH is phenyl, we already know this thing. Got the answer? pH is phenyl, okay? So again you have to check the resonance. You can write number 1, number 2 and number 3. Tell me the answer, Shillong. Second, first and third. Second, first and third. Is this the answer? Have a look again. Do you see any kind of mistake in this order? Second, first and third. Think about it again. See how to judge these orders now. I am able to see that in each of the structure the one phenyl is common. So, just leave the one phenyl which is common. Yes, now the answer is correct. I am able to see that now there is one more phenyl, there is a methyl and there is simple hydrogen. Okay, so methyl will also have the plus sign. If I have two phenyls, it means that positive charge will, delocalize in both of the rings there. So the answer will be second, then third, and then it will be the first, right? Try next question. If any other student having any doubt, you can raise your hand or either type it down, okay? I am hoping that everybody is getting it. This time I have this CH2 plus. I am having NO2. I am having a CH2 plus. I am having a CH3. Do it. Now here you have to think about that which group is releasing, which group is withdrawing. Okay? And you know this thing that the carbocations are stabilized by electron releasing group. See, that is why there is an important thing that you have to, you should know that which are releasing groups and which are withdrawing groups. So this is important. What is the answer? Yes. Which is the most? Second, fourth, third, and then first. I think there is a mistake. Think about it again. You have just check for the groups first along. Second, fourth, third, first. You are saying this thing. OCH3. What about the OCH3? Discussion is going on. Let me give you, okay, I'll solve it, okay. See, NO2 is there. Just look at the screen. NO2, this is a withdrawing group. This is a minus M, okay. CH3, this is plus hyperconjugation. OCH3, and always try to do this question like this, okay. So OCH3 is again a releasing group. Don't take it as a minus psi. I am able to see that there are the electrons. It's a plus M group, okay. So what will be the order now? We have to stabilize the positive charge. It means the more groups which will be giving the electron density will be stabilizing it more. So don't you think that I have two groups which are electron releasing? Methyl and methoxy. OCH3 is methoxy. So OCH3 is giving by the resonance. It is giving by the mesomeric. So it should come in the front, third, okay? Then second, then fourth, and then first. This will be the answer. Take your time, write it down, tell me if there is any doubt. Everybody got it? Okay. Now try one more question related to this type. Try this one. This is the bond I'm making, okay? Try this one and tell me the answer. Now take care of the groups, okay? That which one is the releasing, which one is withdrawing. What is the answer now? Which will be, you can write the, the numbering here, 1, 2, 3. Second, third, first, fourth. You have put the fourth in the last. Why you are so angry with the fluorines along? Did you give the last position to the fluorine? Should we give the fluorine last position? What about the first and the fourth? This is correct. Only a small mistake you have done. See, OCH3 is giving, no doubt. Just check that which are giving and which are taking. This is taking by minus M, right? This is also taking. We know that it's an electron withdrawing, but this is taking by inductive effect. Okay, Shillong? This is taking by the inductive effect. So what should be the order now? It will be the second, then it will be the third. First of all, we have to keep those groups in the front which are electron releasing. Then it's like the simple methyl, like the number 3 option. Then after that, what should I do? Now I know that the first and the fourth both are taking. Both are taking the electron density towards itself. But this is taking by minus I. And this is taking by mesomeric. And the mesomeric are taking more electron density. Okay. So that is why fourth will come and then the first will come. Are you people getting it? Any doubt, Shillong? Okay. Okay then. I hope there is no doubt. Okay, you're finding this easy or tough? I hope you are saying this is so easy, ma'am. We are just doing silly mistakes. The rest of all the things are easy. How many of you are saying that this is easy? GOC till far, which you have started easy. Raise your hands. What happened? I was just asking the question. How many of you are saying that this is easy? Raise your hands. Nobody is raising the hand. Nobody is finding it easy. Okay. Both of the hands are there. Nice. This is easy, right? The only thing is, the things are interlinked. Because if you do not know that what the hell the cyanide is, that what will it do? It's a releasing group or withdrawing group. Then it will be definitely the problem, okay? So, but if you keep on, it's easy if we understand. Exactly this is what I'm saying, okay? That once you just get the concept, then you can just solve any type of the question. That is why it is easy. And the revision is very, very important, okay? Let's talk about, so these types of question, I guess you people can do it now, okay? Tell me about this one also. Tell me about this one. Try this question. First of all, try this. The number 1 and the number 2. And even, I can have number 3 also. This is the positive charge, okay. Now I have 3 options with me. I'm giving you a little idea. Think about the aromaticity here, okay? Then you will be able to solve it. In each of these 3 options, you will be able to see the resonance, okay? But what about the aromaticity? Think about it. CC-Pur Center, are you there? CC-Pur, you are getting the questions? Then why you are not replying for the answers? CC-Pur Center, any doubt? Just write it down. What will be the answer of this question? Shillong. Shillong is in the discussion. Three, 2, and 1. Oh, so Shillong, I guess you have checked that resonance, right? You have idea about the aromaticity or anti-aromatic compounds. How many of you have the idea? Raise your hands. Aromatic compounds, anti-aromatic compounds, non-aromatic compounds. Idea? You have the idea? Anybody? No. Okay, it's a no. Okay, now look at the screen. This question was related to that. If you keep on solving it from the resonance, see, you will be seeing that the resonance is possible in all of these three structures, isn't it? I can draw the resonating structure everywhere. I am able to see that. Now, what you have to do? Look at the screen. For these types of things in the cyclic system, we check about the aromaticity. I guess all of you know that benzene is an aromatic compound. You remember that? So benzene is itself an aromatic compound. I am writing the few things about the aromatic compounds. Look at the screen, everyone. For any ring to be the aromatic, there are the three conditions which should be satisfied. Number one is it should be cyclic. A cyclic compound can be aromatic, a straight chain can never be aromatic, right? It should be cyclic, it should be planar, okay? Planar means generally it will be sp2 or sp hybridized. If I am getting any sp3 carbon, then that is not an aromatic compound, okay? So it should be planar. Then number two, we should say that a complete resonance should be present all over it there in the structure. So complete conjugation should be there, or complete resonance should be there. Should be present in all over there in the structure, okay? So this is what I'm saying. And number three is it should follow the Huckel's rule. Now, do you people know that what is Huckel's rule? Do you people know that what is Huckel's rule? See, Shillong, what happened here is, I am writing here, okay, what is the Huckel's rule? Huckel's rule is like the 4n plus 2 pi electrons should be there, okay? N is any integer, n can be 1, 2, 3, or it can be 0 as well. 0, 1, 2, 3 and up to so on. It's a number. When you put that number, you will be getting again a number that represents the total number of pi electrons which are delocalizing into the compound, okay? Now, just tell me one thing, Shillong, that how many electrons you are able to see in benzene which are delocalizing? How many electrons you are able to see in the benzene which are delocalizing? Tell me. Tell me, because it's important, that is why we are studying it. How many electrons revolve, or I should say how many electrons delocalize in the benzene? Write down. There is some network problem. I am not able to see you all, but just take the help of the screen and just write down your answer. So long center, yes. So 6 is the answer, right? So what value should I put here? Because if I want to check the 4n plus 2 pi rule, that whether the benzene follows the Huckel rule or not. So what value of n should I put? You are already able to see it. See, the 3 pi bonds are there. It means the 6 electrons are revolving. 6 pi electrons are revolving. So what value of n should I put? N equals to what should I write? I should write n equals to 1. When I put the n equals to 1, what value I will be getting? It will be 4 plus 2, that is the 6, and these are the 6 pi electrons, okay? So this is what I was saying. So you have to check that, that whether the compound is following the Huckel's rule or not. All of the compounds which are following the Huckel rule and having the above two properties also are said to be as the aromatic compounds, okay? Clear to everyone now? Is it clear to everyone? Now just check that the first one follows the Huckel's rule or not. So long, just check for this one. How many electrons you are able to see in the first structure which are delocalizing? How many electrons you are able to see in the first structure which are delocalizing? In the first structure. Shillong Center. Tell me. Okay. So how many electrons you are able to see that are delocalizing in the first structure? Yes, exactly. Do not count that positive as a 2 electrons. It's a positive charge. So how many electrons I have? I have only 2 electrons. Is it follow the Huckel's rule? Obviously it will follow. You have to put the n value equals to 0. When you put the n value equals to 0, you will be getting 2. So can I write that this is an example of an aromatic compound? Okay. So first one is an aromatic, and aromatics are always very stable. Try for second one. Try for second one. Does that follow the Huckel's rule, Shillong? The second one. How many electrons you are able to see in the second one? Yes, it is not actually following, because you will be able to see that 4 electrons are present here, right? So 4 electrons are delocalizing. So I cannot put the n value equals to half, okay? Because n should be an integer. It can be a positive integer, or you can write 0, 1, 2, 3, 4, okay? Now what is the special case in the second structure? I am drawing the structure here, everyone. The second structure, what I am telling you, that particularly for this one, in which, all of the 3 things are same. Like this is also a cyclic, this is also planar, and I should say this is also having the complete conjugation. But the only thing was that it is not following the Huckel's rule here. So what rule it is following, Shillong? We used to say it as only the 4n pi electrons, okay? Like here you don't write 4n plus 2 pi. I am writing 4n pi only. So if I put the n value, obviously 0 I cannot put. It can be 1, 2, 3 up to so on. Just check, is it following the 4n pi but not the Huckel's rule? Just check, is it following 4n pi rule? Yes, it is following 4n pi rule. I know that 1, 2, 3, 4. I have the 4 electrons. If I put n value 1, so 4n pi, so that will be the 4 pi. Okay, so this is following. So the compounds which are following the 4n pi rule, okay, are known as the anti-aromatic compounds. So this is for anti-aromatic. So I have told you 2 things here, Shillong. One is the aromatic compound, the other is the anti-aromatic compound. All of the 2 things are same, that cyclic system, planar system, complete conjugation, but the only difference is one is having the Huckel rule, other is having the 4n pi rule. Are you getting it? So this is the case, right? Now we get to know about the aromatic also, we get to know about the anti-aromatic also. Come back to this third number, the option. Can you tell me whether it is aromatic, anti-aromatic, or ma'am, this is nothing. This is not the aromatic and this is not even the anti-aromatic. What can you say about the third number? Tell me quickly. Any idea, any comments about the third number? We have studied aromatic, we have studied anti-aromatic, and anything about or this is not even nothing. This is not even aromatic, not even, anti-aromatic. Tell me, Shillong, anti. How many of you are saying this is anti? The third one, raise your hands. One, two, three, 4. Others? Anybody saying no, this is not even the anti, this is not even the aromatic, this is nothing? Anybody? Raise your hands. Nobody. See, what you have done, you have simply checked that these are the two, the four electrons are present, but you forgot this thing, Shillong. Look at this carbon. Okay, just tell me, is the complete conjugation present in the system? You can only show the resonance till here. What will you do with this carbon? There is no resonance, okay? Plus, this carbon is sp3 hybridized. This is not even sp2, okay? So, I am just telling you that this compound, we can say, yes, the resonance is there, but it is not present all over there in the structure. I can make only the resonating structure till here. Look at the screen. This is the positive charge, right? So everywhere, like this is the carbon, this is the positive charge, double bond, then what is the case here? Nothing. Okay. So I am saying that the complete resonance is not present. Also, that one carbon is sp3 hybridized. So it means it is not fulfilling the first two conditions. Okay. So always remember the compounds which are like this type. Okay. Or like something like this. If I draw this type of system, double bond and a positive charge, I am able to see that resonance is there, but it's not a complete resonance, okay, like for this type of system. So all these kind of compounds which are not related to the anti and the aromatic comes under the category of non-aromatic compound, okay. So this we will write, I'm rubbing it, this we will write as, this is a non-aromatic compound, okay. So I have given you three varieties here. This is anti, aromatic, anti-aromatic and non-aromatic. Now I hope the difference between these three is clear to everyone. Okay. All of the compound in the world, which are not belonging to the category of aromatic and anti-aromatic, all comes under the category of non-aromatic compound. Right? Clear to everyone? Don't worry, we'll take a break, okay? It seems like we people are studying from so long. You need a break? I guess you don't need a break. You are in the full flow of, no, ma'am, we will need a break. Everybody is raising the hand for the break. Okay, just hold on. Let's write the order first of all. So here the answer will be the first, then the third, then the second. Anti-aromatics are very, very unstable, everyone. Always remember this thing. This is a very generalized order that, okay, we will take it, Shillong, we will take it. Aromatic, then non-aromatic, then anti-aromatic, okay? So this is the thing. And I'm writing this order here also. Always remember the stability order I'm writing here. Aromatic, then don't write anti, okay? It's the non-aromatic because at least they have the resonance. And in the last are the anti-aromatics. This is the combined order, okay? So I guess we have done only, from the reaction intermediates, now carbocation is quite lengthy, okay? After the break, we will discuss some few more important points, and then we will discuss the rearrangement because we will be using the rearrangement ahead in the reactions. So we'll talk about the rearrangement. In the very good questions, the examiner do ask about the rearrangement, okay? So let's have the break for the 10 minutes, and I hope you people will be back after the break, okay? So let's have the break for the 10 minutes. Okay, so I guess everybody is back after the break. Let's come back. Oh, Shillong, what is happening? I hope everything is fine over there. And let's start with the few more concepts here in the carbocation. Okay, so we are now, we have understood that how to check the stability orders there in the carbocation, and you got to know about the new concept of the aromaticity, the anti-aromatic compounds and the non-aromatic compounds as well. Okay, now one very interesting point, either you can just write it as the exception. You know, if I ask you this type of question, CH2 double bond CH, let's say if I have the CH2 plus, and let's say if I have the phenyl and then the CH2 plus, and if I have this, do you have any idea that what will be the order here for the stability of the carbocation? I have made an, it's kind of, and you know that this is known as allylic. This is allylic position. When a double bonded system is attached with the sp3 carbon, that carbon is actually known as allylic. Like we used to say that allylic chloride I have. In that case, I will be writing CH2Cl. That will be my allylic chloride, right? And so this is an allylic position. This is an allylic carbocation. This is known as benzylic, okay? Benzylic carbocation. And this already you know, this is a tertiary. It's a tertiary. I'm writing tert over here. It's a tertiary carbocation, okay? Or either we can write simply as a tertiary also. 3 degree you can write, tertiary you can write, tert is also the name. So these are the common names. What will be the order of the stability in this case? Write down the order, 1, 2 and 3, you can just take it and tell me the order. Anyone? Order, what will be the order? Two, 1, 3. Okay. 2, 1 and 3. Obviously, you know, if I ask you this question, as we were doing the question, and I was shouting that the mesomeric effect is more dominating than hyperconjugation than inductive. That is purely applicable, okay? But just remember, there is an exception in this particular case, Shillong, okay? No doubt we are able to see the resonance in the allylic and the benzylic system. But you know, always remember the tertiary is more stable as compared to the benzylic and allylic, okay? So if I have already written it in the order actually, okay? So this is the order. So you can just write that this is an exceptional order. It's an exception, okay? So it's an exception. 3 degree, although there is no resonance, I agree, okay? Because the inductive and the hyperconjugation are so much dominating, okay? And always remember, this is only and only applicable in these 3 cases, these 3 options if we have, okay? So tertiary is there, benzylic, and after that there will be allylic. Some people, they will get confused when I will write this thing. Look at the screen again. Many times what happen is, this I have, you know, people just show their notebook and came as bring it to me as a query. And then they'll point it out, ma'am, you just taught us this thing and we got this order. I haven't talked about this thing. Do you able to see the difference here in this benzylic? In this benzylic, I am already getting an R group here. I got a methyl here. So I am saying that this order will not be valid over here. Obviously, now we have to check the same thing that we were doing. The resonance and the hyperconjugation, everything, okay? But I am saying when I have only the CH2, then this order will be there, okay? So I hope now you are getting the difference. Whenever you see any allylic, benzylic and a tertiary, so that will be the order, okay? But it is not applicable over here when we have any, either I can write methyl, ethyl or any R group. If there will be any R group, you know, the order will get changed. So that was an exception, do remember that. and I just checked that all of you are now added into the WhatsApp group. Why? Okay. Actually, there is no as such a complete or a sensible reason behind that. It's actually the main reason is here because when you compare this thing, na, Shillong, what happened in that case, and there is no actually a perfect reason behind this that this is why this is happening. Because what happened in this case, like if I take this type of compound, CH2Cl, how it came to notice and why we are studying this, I'm telling you. And when I write this, and I can write any of the SN1 reaction here. We'll discuss it later on, although you have the idea. So if I just write one SN1 reaction for both of them, I know that I will be getting the carbocation, right? The chlorine, the chloride goes away. I will be getting a positive charge here. I will be getting the positive charge here. So what happened in that case, we were getting the more product or the faster product here in this second case. From there we get to know that if the rate of reaction of the second reaction is faster, it means the corresponding carbocation was more stable in that case, okay? From there experimentally we get this thing, and that is why we are studying it here, okay? So this is actually the reason. You got it now, Shillong? Okay, so these are the kind of the things, and you will get to know that some of the more exceptions we will do when we will talk about the acidic strength and the basic strength, okay? So that is the case. Okay, so we have done this thing, and yes, what I was telling you, that I have just checked in the break that you people, we all of us are connected on the WhatsApp group now. So I will be sending you the assignment today itself, okay, related to all of the things which we have studied. Now it's your duty to solve the question, because this I actually do in my classes here in the Delhi also. I send one assignment, people used to give the answers there and solve them, or they can discuss it. And obviously if you people will be, I'll be having the good response from your side, then I will be sending the level 2 questions also. But obviously if you people do not solve the level 1, then why would I will be sending the more and more questions? I have a complete book related to the NEET questions. I have the mock questions with me. So no need to, search all of the questions here and there. I have a bunch of questions related to one particular topic. And if you want, we can practice the different types also. Okay, the MCQs are there, single correct choice are there. So this is how we can proceed further. Okay. And now coming back to that carbocation part, let's talk about the next very important topic in the carbocation itself. It's the rearrangement. Rearrangement in the carbocation. It's only this intermediate in which the rearrangement is possible, okay? So rearrangement. How many of you already have the idea of rearrangement? Raise your hands. Have you studied? Have you seen the rearrangement in carbocation in the reactions? There is kind of the group shifting. You know this thing? How many of you know? Raise your hands. Nobody knows? Okay, no worries, we'll study it. Now see what happened in this case. In order to make our carbocation more stable, we used to do some kind of rearrangement, okay? So I am writing the very first type here. It is known as the group shifting. Group shifting. I am writing the first case of the group shifting. Let's say if I have this 1 degree carbocation, are you able to see that I have a 1 degree carbocation? I've just tried to make the structure a little bit in an expanded form. Okay, a carbon is there attached with the methyl, 2 hydrogens are there, and a CH2 is there. Now what I'm saying, if I have to make my carbocation more stable, This is a 1 degree carbocation. If I, just swap the position of a hydrogen with the positive charge, what will I get? What will I get? I will get the positive charge on the second number of carbon. What I am saying, look at here on the screen. CH3, this carbon, hydrogen, positive charge, CH2, and I have just attached one hydrogen here. Are you able to see the difference? Or I should draw it here because let's not make it more confusable for you. I have nothing I have done, I have just swapped the position of a hydride, of a hydrogen with the positive charge. This is known as, like if this is 1, 2, because the first number carbon will be the CH2 plus, it's a 1, 2 hydride shift. Now, can you tell me that the drawn structure, the structure which I have drawn, if I just write it like this, it looks like this one, CH3, CH with the positive charge and a CH3. Don't you think that this is a more stable structure as compared to the first one? Because now I got the carbocation as the 2 degree. This is a 2 degree carbocation, okay? So this type of group shifting is possible. So whenever you make a 1 degree carbocation, it will shift and you can make a 2 degree carbocation. That will be more stable, right? Clear to everyone? Any doubt in the hydride shift? Clear? Nice. Let's come to the second one also. 3 types of shifting are possible only, okay? Let's say if I don't have the hydride now, but I have a methyl. What will I do now? Think about it. Still the carbocation is 1 degree, but I am saying that I don't have the hydrogen now. I have all of the methyls here. So you can just, as similar as that, you can shift the methyl here. So I can write it's 1, 2 methyl shift. So methyl do have the tendency to swap the position. Just try and you people will tell me that what degree of carbocation you are getting. Just swap the position of 1 methyl with the positive charge and tell me what degree of carbocation you are getting. Got the answer? How many of you got the answer? What degree of carbocation you are getting? Two degree or 3 degree? Think about it. 2 degree you are getting or 3 degree you are getting? Do you know now how to check the degree of the carbocation? Just check with the carbon. 3 degree. It will be 3 degree. Look at the screen. I am making the structure. This is a methyl. Let's say this is a methyl. This is the positive as it is, or the swapped one. And here I can write the CH2 with the CH3. See, have a look. Clear now? So from 1 degree we are getting a 3 degree carbocation, okay? So obviously, by the methyl shift this can happen. That is why we are making it, we are doing the shifting here. Clear? Now, third type of shifting is the phenyl. Always remember only 3 migrations can take place. One is the hydrogen, one is the methyl, other is the phenyl, okay? So what if I am writing like this? I have 3 phenyl groups with me, along with the positive charge. Now I don't have the hydrogen, I even don't have the methyl, so what will I do? I will shift the phenyl, okay? Some people, just it's difficult to digest that, ma'am, phenyl is going. It's such a big, huge group. I'm saying it's okay. Let it be, because after when you get the carbocation there, your carbocation will get, the resonance from the two of the phenyls here. So it's 1, 2 phenyl shift. How many of you are getting the same answer that I have drawn on the screen? Okay, very nice. So you got it right. And sometimes the people do cram. That first this will go, then this will go, then this will. No need to cram anything. The only thing is, if you want to make the choice, right, that whether I have to shift the hydrogen or the methyl or the phenyl, if let's say you are getting all of the three options there, then I am saying that you will be picking that particular group that after doing the migration, my carbocation will be getting more stable. So you will be doing that kind of migration, okay? So let's do the question now, okay? Try the question. Write, or you can write the most stable structure after rearrangement. Try this one. You people will tell me. This time, I have given you methyl also, hydrogen also, and a phenyl also. Which group you will migrate in order to get a more stable structure? I guess the second one is the easier one, so you can either try the second one first. Both of them are easy, okay? Just try it. It's the pH is the phenyl, okay? What is the answer? In the first one, which group I should remove? Or with which group we should do the rearrangement? Okay, how many of you are saying the hydrogen? In the first question, how many of you are saying hydrogen? Raise your hands. Very good. Hydrogen is the answer. In the second question, how many of you are saying hydrogen? In the second question also. Okay. Yes. So obviously it's the hydrogen, right? So we will be doing the hydride shifting. It's 1, 2. You can write the hydride shift. Same thing you can write here. It will be the hydride shift. Because, just after removing the hydrogen, you will be getting the more stable carbocation, okay? So it's the CH3+. I'm making the structure, everyone. Just check it out. CH3 carbon and the CH3, here is the positive charge, and then again the CH3. Clear to everyone? I guess there is no doubt now. Let me give you one more interesting question then. This is the bond line structure, right? So think about it. Either you can tell me that there will be a shifting or there will not be any kind of shifting, or if you are making this shift, then which group it will be. Think about it. It's a bond line structure. You know, the hydrogen are not shown to you. And that particular group will be the methyl. So what is the answer, Shillong? Okay, I am making a structure. No shifting. How many of you are with the no shifting? Raise your hands. How many of you are with the no shifting? Raise your hands. Okay. Okay. What about others? Why there should be no shifting, Shillong? As I have just said, you get confused. Look at the screen. Don't you think so that this is a carbon? This is a methyl group. This is again a carbon. It's a carbon and it do have a hydrogen. Don't you think that I can have the shifting of this hydride? If I get the hydride shifting, what will happen? Look at here. I get the positive here. And what else will be left? You know, that particular hydrogen. This particular hydrogen, I'll get at this position. So this was the 2-degree carbocation and now I get the 3-degree carbocation. There will be shifting and that too will be 1, 2 hydride shift. Think about it. Is it clear now to everyone? Any doubt? If you have any doubt, just let me know, okay? Now try this question also. This time I have given you 2 methyls and this is the positive charge. Which type of shifting will take place? Yes, Long. Okay, how many of you are with the no shifting again? I guess that will not be the answer of any of you. Obviously, there will be the shifting. I'm making a structure, okay? And then you people just check if you got the same structure or not. How many of you got this structure? Raise your hands. Okay, 1, 2, 3. Very nice. Oh, okay, that is nice. Yes, so it is the methyl shifting, right? So it's the methyl shifting. So you don't have the hydrogen this time. I have the 2 methyls. So I just shift the methyls. It's a 1, 2 methyl shift, okay? And this is also easy, right, Shillong? I hope everybody's, considering it as an easy topic. It's an easy thing, Once you get the concept again, you can just draw the structures. So this is all about the group shifting, right? This is all about the group shifting. But there is one more case, because it's also an important thing, so I will be telling you that also. Number 1 we have done is the group shifting. There is one more case that is likely to be there in the cases of the rings only, okay, in the cyclic structures only. So I am talking about the bond shifting. Let's write the next thing here. I am talking about the bond shifting. It is typically for those type of compounds that when positive charge is present adjacent to the ring. And this is more commonly for the 4th and the 5th member ring, okay, 4th and the 5th member ring, this is commonly for them. When the positive charge is present to just the adjacent carbon with the ring, then, like if I tell you, let's take an example. What if I give you this question, and I haven't taught you about the bond shifting, but let's say if I have given you this question, what you people will do? Think about it. Think about something about the group shifting, okay? I am not I'm not telling anything about the bond shifting right now. I'm saying I have given you this question. You already know the group shifting. Just do that and tell me what you are getting. Check which group you will shift. And then tell me what degree of carbocation you are getting after your group shifting. What degree of carbocation you are getting, Shillong, after the group shifting? Yes. Very good. Hydrogen shifting. Then, this is correct. What the degree you are getting? Okay, I am making a structure. Like what the most of the people do, they will do. This is the hydrogen. Those who don't know about the bond shifting, what they do, they say that, ma'am, this is the hydrogen. Obviously, we are having one hydrogen over here, and we will, just do the shifting of this one. So we will be getting the structure like this. Here is the positive charge, and this CH2 is now actually the CH3. How many of you are getting the structure which I have drawn in the blue color? Raise your hands. Exactly, okay. So this you will get after the bond shifting, and you will be getting a 3-degree carbocation. But I am saying that when you see this type of compound, you will not be doing this, okay. You will not be doing this. Why? Because what happened in the cases of the ring always try to expand, okay. I hope you already know that a 3-membered ring is a very strained ring, okay. 3-membered ring is a very strained ring, then 4-member, then 5-member, then 6-member ring. So when we have this type of compound, this ring will not do the group shifting, because after the group shifting, no doubt we are getting a 3-degree carbocation, but that too in the 4-member ring. So ring will try to expand itself, okay, and how the ring expansion is done. So we will be writing here the ring expansion. Or I should write it here only. The group shifting is actually the case of ring expansion. Now look at here what I will be going to do. Everyone, first of all, look at the screen, then you people can note it down. I was having this type of structure. I'm making again in the bond line form. So what I have to do, I have to break one bond, and I will make a bond with this carbocation. Okay, let's look at the screen, everyone. Just look at the screen. So what I am doing, let's say this is the bond. I'm breaking this bond. I've just marked it with the red color. I'm breaking this bond and I'm making a new bond here. Okay, so how will it look like? Keep on looking at the screen. Don't you think that it will look like this type of system? Okay, and can you people now tell me that where will that positive charge go? You have broken the bond with this carbon here, right? And you are just putting it and attaching with some other carbon. So where will that positive charge go? This positive charge will come at this carbon here, okay? How many of you got the structure? Raise your hands. I have just broken one bond and attached it with the another carbon. And from where your bond is breaking, you will get the positive over there, right? Are you getting it? Now you can just make it into the more simple form, because we are having the habit of seeing these pentane, the cyclopentane in this way. So I can make the cyclopentane in this way, and now I can have the positive charge here. Okay? So this is actually the answer. This is actually the ring expansion, that from a 4-membered ring, I get a 5-membered ring, that is a cyclopentane. Just note it down. So we will not be performing this method. We will not be performing, you can just make a cross. We will be doing the ring expansion, and this is right. Got it? Any doubt to anyone? To any of you? Nobody is having the doubt? Everybody got it? Okay, then try this question I'm giving you. And I hope everybody has written it. Let's try one more question. This time I'm giving you a pentane, and here is the positive charge. Try to, do the ring expansion, everyone. Try to do the ring expansion. And I will tell you that why these type of things are important, okay? These are not, though, even not in detail in the NCERT. They have just written the word of rearrangement, but they haven't shown the structures there. It's the similar kind of structure you will get, the process is same. Try it and then tell me what you are getting. Cyclohexene or cyclohexane, Shillong? Cyclohexane, right? Okay, I'm making it. See, and you can just take the any side, okay? Let's say I'm taking this side. I will be breaking the bond, so it will look like this one. It's a kind of, it looks like a cattle. It's not a cyclohexane, okay? Do write as cyclohexane. And where I will be getting the positive charge, I will be getting the positive charge here, okay? So from where you are breaking the bond, now that particular orbital is vacant, okay? So you have to, that particular has not having the complete 4 bonds, so you have to make the positive there. So I can just make it in the full flesh form, It will be like this, and now all of the carbons are equivalent. So you can just make the positive anywhere, no problem. Okay? How many of you got the same structure? Raise your hands. Okay, many of you got. Very nice. It's a cyclohexane. Okay, do write the word cyclo. So this is the case. Now one very interesting thing. If I give you this question, I am already giving you a 6-membered ring, and let's say I am giving you a positive charge here. Now the question is, will you perform the ring expansion here and you will be making a 7-membered ring? No. Everyone listen to me. Only we used to make the rings from 4-member to 5-member or 5-member to 6-member. That's it. Now it's not like that always you will be doing the ring expansion. The 6 is already the most stable ring. Okay. The 6-membered ring, we considered it as the most stable ring. Okay. So we will not be expanding it. So what we will be doing? We will not be expanding it. So what we will be doing, I am saying that there will be no ring expansion, but we can do the hydride shifting this time. Okay. So if I ask you the question that whether there will be rearrangement, you will be saying yes ma'am, rearrangement will be there, but we will not be performing the ring expansion because 6 is already stable. So you will be doing the hydride shifting here only. Okay. And you will be getting this as the answer. Got it? Everyone? Very nice. Try one more question of ring expansion. Try this question. This is for the ring expansion, okay? Just check what you are getting. And in this question, you have to do the shifting 2 times. First of all, make the ring, make the 5-membered ring, and then think what is the next possibility there. So what you are getting, Shillong? Okay, just tell me one thing. What is the degree of carbocation you are getting? What is the degree of the carbocation in the end you are getting? What is the answer? I'm waiting. What is the degree of carbocation you are getting? 2 degree or 3 degree? I know that. How many of you are getting 2 degree? Raise your hands. After the ring expansion, what the degree you are getting? Obviously, you will be getting the 2 degree. But I am saying, Shillong, don't stop at 2 degree. Think, there is one more option. You can, just make one more migration, one group shifting, and you can bring it to the 3 degree. So, the rearrangement goes on till you reach up to the maximum finalized, the most stable carbocation. Then you have to stop there, okay? Okay, those who are not getting, look at the screen. I am making the structure. See, I am breaking the bond. Yes. How many of you got 3 degree? Raise your hands. How many of you got 3 degree? Yes, okay, so 3 degree will be the answer, right. So this is the bond, I'm breaking this bond, and I am, just doing like this. This is the case, I will be getting the positive here. If I make it in a more clear way, I will be getting something like this. Everyone just look at the screen, how to do that. Let's say if I am making methyl here, I know that on the adjacent side I have the positive charge. So I can make it at any side. Now one more thing I am saying, do not stop over here, because I can just do one group shifting now, and I will be getting the more stable product as this one. Okay, so this is the finalized product. This product is the last carbocation is the most stable one. Okay, so these types of questions are very, very common, in which we have done the two types of rearrangement. The one is the ring expansion, then we have performed the group shifting here. Okay, everyone got it? So the answer will be this one, which I have drawn in the red color. Okay, so we are just done with all of the the rearrangements. I hope you got the concept now. There will be no doubt. Okay, so the next topic is carboanion. We still have 10 minutes, so we can start it, but the stability questions we will discuss in the next class. Okay, so let's write carboanions. Now you people will tell me, let's say if I am writing the carbanion CH3 negative. Negative means it's half the lone pair, right? Tell me the hybridization, tell me the geometry, tell me the shape, and whatever you know about this particular species, CH3 negative. Quickly write down the answers, I'm waiting. Okay, just tell me first of all for the hybridization. How many of you know the hybridization? And the carbanion can be of any type, so it can be CH2 double bond, CH negative. I have just chosen the one very simple example of methyl. So it's a CH3 negative. As you know that, it's something, don't you think it's look like similar as of the ammonia? NH3. NH3 which is having one lone pair over there, okay? So NH3 is sp3 hybridized. You used to count the steric number there. So it's not sp2 Shillong, it's sp3. 1, 2, 3, 4. Okay. So 4 is the steric number. So if 4 is the steric number, the hybrid, it means that 4 orbitals are mixing. So just you have to pick the 4 orbitals. 1 is the S and 3 P. That is the meaning. And same is the case with the CH3 negative. 4 is the steric number. Negative charge means you have a lone pair over there. So it's sp3 hybridized. If this is sp3 hybridized, remember, geometry is again tetrahedral because geometry is fixed for the particular hybridization. But here we will be calling it as a shape. So shape will be pyramidal. You know this thing that ammonia is pyramidal? How many of you know this thing that sp3, the shape will be the pyramidal? Raise your hands. Okay. Fine. So can I say that this is an electron-rich species? Carbocation was electron deficient, but this have the electron, the octet is already completed. So this is an example of an electron-rich species, right? And what will you do now if I want to write that here stability of carboanion will be directly proportional to what? Tell me, electron releasing or withdrawing groups? If I am saying that I want to stabilize a carboanion, it means I want to minimize that charge. If I want to minimize that charge, which groups will, stabilize it? Think about it. Releasing or withdrawing? What is the answer? Electron releasing group stabilize the carbon ion or electron withdrawing? I'm waiting for the answer. Type it down. Electron withdrawing, exactly, okay? So EWG. Because you already have the electrons, you have the negative charge, you have to take the electrons from it. So then it will become more stable, okay? So it's the electron withdrawing, and I can write like -M groups, -I groups, these types of groups, right? Let's do only one question, and then we will be doing the rest of the question in the next class. And I guess we people have one class in this week, one more class, okay? So I guess we will be completing the GOC then. Try this one, okay? It's like CH3. I have made a triple bonded carbon having the negative charge. Here I am making a double bonded carbon having the negative charge. And here I am making a simple alkane having the negative charge. Now you people will tell me the stability order here. Quickly. What is the answer? Any idea? This time I haven't drawn any kind of group here that you can, take the help of electron withdrawing or anything. This question is itself a concept here, okay? That is why I have written this thing. A sp carbon is there, a sp2 carbon is there, and a sp3 carbon is there. Do you know the electron negativity order of these types of carbon? How many of you know? Raise your hands. You have written the complete reverse order. Shillong, look at the screen. Let me tell you. See, first of all, if those who are, the concept is not so much clear for the hybridization, I would, suggest you to please have a look on how to find the hybridization. If you still didn't find it, and if you still find any confusion, then you can let me know. I will explain it, okay? So I am just saying that this is a sp carbon, this is an sp2 carbon, and this is an sp3 carbon, okay? It's an sp3 carbon. So you should know this thing, that electron negativity order. Anybody have the idea? What is the electron negativity order in these carbons? Just raise your hands. I just want to know how many of you have the idea. It's everything from the chemical bonding, It's like bonding is very, very important chapter. How many of you have the idea? Nobody have the idea, I guess. Sp are the more electronegative carbon, then sp2, and then sp3. The reason is the percent S character. In sp, 50% is there. In sp2, 33% of S character will be there. And in sp3, only 25% of S character will be there, right? So this is the reason. And you know these things. If I am saying that I just want to know that which of the negative charge is stable, what will you do? If I ask you this question, you already know the answer. F negative and O negative and carbon negative, which is more stable? You will definitely say, ma'am, F negative is stable because fluorine is more electronegative, right? So electronegative atom can, just make the negative charge stable over themselves, okay? Or they can keep the negative charge over themselves happily. So this is the reason here the stability order will be like first, then second, then third, okay? Because sp is more electronegative, so the sp carbon can keep the negative charge over itself. It will stabilize the negative charge. And this is again important thing, star mark it. and please do remember it. Should we do more? We are done or should we do more? See, I am asking you people. Oh no, ma'am, it was a long class. Okay, we are not doing more, but I am again saying to everyone that please make sure that you people will be solving the question. I will try to post it by today itself. Okay, just after your class, I will make an assignment for you, and that assignment will contain all of the previous concepts. Okay, which we have covered. The assignment will be typically related to the GOC questions. Okay, I will see if I will be giving the options or not. But it's now your duty to solve the questions, to do that assignment. It's very, very important, because if you are not solving the question, if you are not, because every question is having so much variety of the concept in there. Okay, so it is very important. If you are solving any kind of book, that is very good. But if we are not solving any other kind of material, then at least we have to solve these assignments. Okay, so and I will be expecting that you people will be posting the answers in the respective groups. And because I actually, Shillong, I feel that the dropper students are quite sincere, and they will be definitely doing the assignment. Okay, then see you in the next class. In the next class, we will be talking about more about the carboanions, radical, and start with the acidic strength. Okay, I guess 1 or 2 class more, then we will be completely done by the GOC, right? Okay, then thank you so much. Bye bye. See you in the next class. Please do the assignment. Okay, thank you.